The final analysis that we're going to carry out in Jamovi is a linear regression. Simple linear regression and multiple linear regression. We use a regression when we want to predict a value, not a yes, no, or categorical outcome, but a value like a starting salary. First, I'm going to check my data, and here is my starting salary, but look at these 3 circles up here. That means that this is a categorical variable at the moment. I need to change that to something we can count, a continuous variable. I'm going to click this here and then it's ready for us to use. Note how salary would normally have a comma if it was for human use. Machines like machine-readable data and are often less flexible than tools like Excel or a spreadsheet in Google. Sometimes we have to clean up our data before we can get it to work in a specialized tool. Now my data is ready, let's walk through running a linear regression in Jamovi. Our goal is to test how well our predictors explain changes in our continuous outcome variable. Holding all variables constant, that means we look at the impact of one variable, not all of them together. Under Analyses, click Regression and then Linear Regression. As before, this is the variable we're trying to predict. We would like to predict starting salary. And here I can add my covariates. These are the things that I believe will explain my data. I think GMAT scores and work experience in years may be impactful. If I would like to divide this data, say national and international students, I would drag that one into the factors section. Okay, let's configure the model metrics on the left-hand panel before we look at the output. Let's configure model fit, expand that menu, check that R squared is ticked and also check adjusted R squared. This gives us our overall model fit. Then check model coefficients, expand the model coefficients menu. We would like to get a standardized estimate as well, so we can directly compare which predictor has the strongest relative effect. And I'm going to check the confidence interval. This will show our estimation precision. Finally, come back up and open assumption checks. Remember we said multicollinearity is a problem. If you have variables that are extremely similar, they can create problems in the analysis. I'm going to tick collinearity statistics, and that will give me a VIF value, which I can interpret later. I'd also like to see what it looks like. So here in assumption checks, I'd like to see the residuals plot and then the QQ plot of residuals. And this gives me the line of best fit, and I can see how my data points line up. Let's check our model fit measures table. Look here. This tells us our R square and our adjusted R square values. We want to make sure that our p-values are below 0.05. This tells us that our model is statistically significant. We want to check our VIF value. We're looking for a VIF value that is under 5. If they look good, our assumptions about the model hold and our model interpretation is valid. I'm going to export all of this so I can check this against my criteria. Remember to get it out of the cloud and onto your laptop so that you can attach this with your report at the back. You're going to need to come to the hamburger menu. Don't click save, nothing is downloaded yet onto your laptop. Click export. You have a range of options. I'm sure the PDF will suit most purposes. Export your model. And now all of this output data will be sitting on your computer in your download file so that you can use it in your report and in your appendix.